This next video is going to discuss how to get a centering matrix. Now the formula we use in video 3.15 for obtaining deviation scores from raw scores can be reworked to obtain an equation for a centering matrix. That is, a matrix that will center the raw scores by turning them into deviation scores, which by the way are centered around 0. So just for recall, we did this equation, had this equation in video 3.15, which was to obtain deviation scores from raw scores, and our raw scores were in a matrix Y. You can actually rework this. You have an identity matrix times Y, which will just give us that Y matrix. Okay, so that's the same thing. And you notice we have a Y over here and a Y over here. So we can actually factor that out. Get I minus 1 over n times j, and we're factoring out our Y matrix. Okay, so you notice that we could put Y back here and Y back here. Okay, this is actually equal to the centering matrix times our Y matrix. Thus, our centering matrix, which we are calling Q, equals the identity matrix minus 1 over n times J matrix. And this Q matrix is an n by n matrix, or a square matrix, where n is your order, or the number of observation units. So in the examples we've been doing, we've had a Y that was 5 by 3, and so our order is n, and Q will actually be a 5 by 5 matrix. So let's do this. Q centering matrix, I'm just going to write this out again, times J. It's going to look like this. Our identity minus 1 over 5 times J matrix here. Alright, I zoomed out here so I can have more room to do this. So let's simplify that. So this is going to equal our identity matrix minus, and all of these will just turn into 1/5. Sorry, I didn't extend that far enough. Alright. So now you just subtract. So what we'll get is 4/5. If you notice, this is just going to be negative 1/5 across the rest of them. And also down here it's going to be negative 1/5. In fact, wherever there are zeros, it's going to be negative 1/5, and where there are ones, it's going to be 4/5. So 4/5 along each diagonal. And for the sake of time and bearing you from watching me write all the fractions, I'm just going to write it like that, but you can imagine the rest is filled with the -1/5. Now this is our Q centering matrix. It centers matrix Y by turning it into a matrix of deviation scores, small y, when the matrix Y is pre-multiplied by it. So let me demonstrate that. So we've got Y, so a Q centering matrix times Y matrix. I'm just going to write Q as I did up above. Four-fifths on the diagonals. Times, if you recall from the previous videos, our Y was a 5×3 matrix of 5, 0, 9, 8, 7, 6, 6, 7, 8, 4, 5, 10, and 2, 1, 7. And this is going to give us 0, -4, 1, 3, 3, -2, 1, 3, 0, -1, 1, 2, -3, -3, -1 when you do that matrix multiplication. So if you notice, this is actually the same result that we got in video 3.15, where we did this equation up here. So we did obtain a matrix of deviation scores of a matrix of raw scores using this J matrix. Now we've used this Q centering matrix, the centering matrix, which centers this matrix Y by turning it into a matrix of deviation scores. So let's show this in Excel. I like it a lot more in Excel because you don't have to write out all these fractions. Okay, so what I did here, I've got our identity matrix set up here, our J matrix, our Y matrix, and right here is what we got from video 3.15 using a J matrix to find deviation scores. Now let's demonstrate how to get this centering matrix, which we know through algebra is equal to the identity minus 1/n, and in this case our n is 5. And you multiply that by this J matrix. So let's do that here. I'm going to put parentheses minus 1/5. That's going to be times this J matrix. Control Shift Return. I'm just going to highlight the diagonals in a different color to make it easier to see. So you see we have 4/5 on the diagonals and -1/5 everywhere else, and that is our centering matrix. Now let's use that to do what we just did to get the deviation scores Y here. So this Y is equal to this centering matrix here times our Y matrix there. So let's do that matrix multiplication. Take our centering matrix, comma, Y matrix, Control Shift Return. And you compare these two and we get the same thing. And also let's show that here. We do get 0, negative 4, 1, 3, 3, negative 2, 1, 3, 0, negative 1, 1, 2, negative 3, negative 3, negative 1, which is the same thing that we got in Excel. And that is how you get a centering matrix and use it.